The night sky is evolving rapidly, and experts are warning that in just a few years, or perhaps even sooner, it may become unrecognizable. Renowned astronomers like Neil deGrasse Tyson have acknowledged the inevitable fate of Polaris, the North Star. This star, a long-standing guide for sailors and stargazers alike, is approaching a crucial turning point, and its story is fascinating. For centuries, Polaris has been a steady presence in the sky, providing a reliable point of navigation. However, recent research suggests that this could soon change. In September 2023, a paper presented by the Royal Astronomical Society raised concerns about the future of Polaris, suggesting that the star could be on the verge of exploding, potentially disappearing from our night sky permanently. To understand the significance of this, we need to learn more about Polaris itself. Polaris, also known as the North Star or Pole Star, is unique because of its proximity to the celestial North Pole. Located nearly directly above Earth's North Pole, it appears almost fixed in the northern sky and resides in the constellation Ursa Minor, the Little Dipper. Polaris is a giant yellow-white star, much larger and brighter than our Sun. It's part of a complex triple star system with two stars, Polaris A and Polaris B, forming a binary pair, and Polaris B orbiting them. The gravitational interactions between these stars influence their orbits and behaviors, and disruptions in these interactions can lead to irregular variations in the star's brightness or pulsation patterns. Despite this, the exact mechanisms behind these interactions remain unclear. Polaris is about 323 light-years away from Earth, meaning the light we see from it today left the star over 3 centuries ago. If Polaris were to explode, we wouldn't see it until more than 300 years later. It's even possible that Polaris has already exploded, and we are just waiting to witness the light from that event. Throughout history, Polaris has had significant cultural, navigational, and symbolic importance. Its fixed position made it an essential tool for ancient mariners, allowing them to navigate the seas and land. Symbolically, it has represented steadfastness and direction, remaining constant in the changing night sky. For astronomers, it has served as a reference point for studying stellar behavior and variable stars. As a Cepheid variable star, Polaris undergoes periodic variations in brightness, providing valuable insights into stellar properties. These predictable changes also played a key role in measuring vast astronomical distances. Recently, however, Polaris has started to show unusual patterns. Instead of following its typical pulsation cycle, it has exhibited irregularities, prompting concerns that it may be nearing the end of its life. Such anomalies are common in stars approaching their demise. Over time, Polaris's pulsation period has been increasing by 4.5 seconds per year, which might seem insignificant, but it holds important implications. Some astronomers believe the gravitational interactions within its star system could be responsible for these changes, while others are more concerned that it is nearing the critical point of exploding, similar to the behavior of Betelgeuse, a well-known star in the Orion constellation. Both stars have displayed unusual changes in brightness, leading to concerns about a potential supernova. While NASA has raised concerns about Betelgeuse, Polaris has not yet attracted the same level of attention. As a Cepheid variable star, it is in the final stages of its life cycle. It is currently undergoing helium depletion, a process common to massive stars nearing the end of their lives. These changes in its pulsations align with patterns seen in stars before they reach their final stages. Although it's not certain that Polaris will explode, astronomers are closely monitoring these developments to understand the star's fate. If Polaris were to explode in a supernova, it would be an extraordinary event visible in the sky, likely becoming one of the brightest objects in the sky for days, weeks, or even months. It could significantly alter our view of familiar star patterns like the Big Dipper and Ursa Major, of which Polaris is a part. However, Earth would be safe, given the star's distance from us. While the explosion might not be as visually striking as Betelgeuse's potential supernova, it would still be noticeable to the naked eye for a prolonged period. Even though the event would likely captivate astronomers and stargazers alike, its impact on Earth's atmosphere or environmental systems would be minimal. What will happen to Polaris itself, though? When massive stars reach the end of their life cycle, they often explode in a supernova, causing their core to collapse and triggering a violent shockwave. However, Polaris isn't massive enough to undergo such a dramatic end. Instead, as it runs out of nuclear fuel, it will shed its outer layers and transform into a white dwarf. This process will not result in a supernova but rather a more peaceful transformation, ultimately leaving behind a small, incredibly dense stellar remnant, a white dwarf. The core of a low or medium-mass star, once it has exhausted its atomic fuel, becomes extraordinarily dense. Can be about the size of Earth but as massive as the Sun. When this happens, the remaining material of the star is no longer considered the same as we observe the star today. Understanding the distinct processes of a Polaris-type explosion, when compared to true supernova events, provides valuable insights into stellar evolution and their ultimate fates. Studying cosmic explosions like SN 1987A and later events such as SN 2011 Fe or SN 2014 J reveals crucial information about the outcomes of such blasts. For example, SN 1354 led to the creation of the Crab Nebula, which continues to expand and emit radiation across various frequencies, offering astronomers a rich field of study. SN 1987A, observed in the Large Magellanic Cloud, provided insights into nucleosynthesis patterns and the mechanisms of supernova remnants, including phenomena like nebula formation and the release of high-energy particles. The formation of nebulae like the Crab Nebula results from material expelled during a supernova blast, which then interacts with surrounding interstellar gas and dust, enriching it with heavy elements. This contributes to the cycle of stellar birth and death. Additionally, the release of high-energy particles driven by supernova shockwaves has significant implications for astrophysical processes and cosmic radiation environments. To make a comprehensive comparison, scientists are examining the differences in the large-scale distribution and velocity of materials expelled in the expected Polaris explosion versus observed supernova events. This includes studying light curves, spectra, and remnants, which can help extrapolate the potential outcomes of a Polaris-related explosion. By investigating the pulsational variability of stars nearing their end stages, researchers hope to identify commonalities or deviations and gain insights into the processes that lead to such catastrophic events. The variability in stars nearing the end of their lives may indicate internal instability or impending destructive events, providing clues about the processes that drive supernova explosions. Despite extensive observations and research, astronomers remain puzzled by the anomalies observed in Polaris's behavior. Understanding the causes behind these peculiarities could offer deeper insights into stellar evolution. Interdisciplinary collaboration and the development of advanced theoretical models and observational techniques are essential for unraveling these mysteries. The potential loss of Polaris as a key reference point in the night sky raises important questions for astronomical research. Ground-based telescopes and space measurements would need recalibration, impacting the accuracy of large-scale measurements. The absence of Polaris could also disrupt navigation systems and cultural practices based on celestial landmarks, highlighting the significance of this event. The peculiar behavior of Polaris underscores the need for further investigations to deepen our understanding of stellar dynamics. The fate of Polaris remains uncertain, and only time will reveal its true nature. However, the ongoing pursuit of knowledge in the face of vast uncertainty is a testament to humanity's enduring curiosity about the universe. The implications of Polaris's potential demise extend far beyond scientific interest. They touch on how humans perceive their place in the cosmos. Throughout history, celestial bodies have served as markers of time and navigation, guiding travelers across uncharted waters and lands. The disappearance of such a prominent star could alter not only navigation techniques but also social myths and symbolism tied to the North Star in various cultures. For instance, Native American tribes often regarded Polaris as a guiding light, symbolizing hope and perseverance. The ancient Egyptians also used the North Star in their architectural plans, aligning pyramids with its position. The loss of such a significant star could disrupt cultural stories and reshape the narrative of human experience related to navigation and direction. Furthermore, the scientific community would face substantial challenges if Polaris were to vanish. Many astronomical measurements and observations depend on established reference points. Polaris's steady presence has facilitated the calibration of instruments and models used to study distant galaxies, stellar evolution, and even the expansion of the universe. Its sudden disappearance would necessitate recalibration of many systems, potentially leading to errors in measurements and interpretations of cosmic phenomena. As astronomers turn their focus to studying Polaris more closely, advancements in spectroscopy and photometry are allowing for greater detail in the examination of the light emitted by stars. These tools help scientists detect minute changes in brightness, which are crucial for understanding the mechanisms that govern stellar behavior. With more data, researchers hope to refine models of stellar evolution, particularly for stars in their later life stages. Studying other similar stars, such as red giants and supergiants, could provide valuable insights. For instance, by comparing the behavior of these stars to that of Polaris, astronomers aim to gain a clearer understanding of stellar dynamics and evolution, enhancing our understanding of the universe's design. Additionally, as the search for exoplanets intensifies, the study of Polaris and its companions becomes increasingly important. Understanding the characteristics of stars in triple systems can offer key insights into the formation and habitability of planets orbiting them. Astronomers are particularly interested in how such stars affect their environments, which could have significant implications for the conditions under which planets form and evolve.